Welcome to today's KMWorld webinar, brought to you by Factor. I'm Mary D. Ojala, Editor-in-Chief of KMWorld magazine, and I will be the moderator for today's broadcast. Our presentation today is titled The Power of Context, Using AI and Knowledge Graphs to Enhance KM. Now, before we get started, let me explain how you can be a part of this broadcast. There will be a question and answer session, so if you have a question during the presentation, just type it into that Ask a Question box and click on the Submit button. We will try to get to as many questions as possible, but if your question has not been answered during the show, you will receive an email response within a few days. And now to introduce our speakers for today. Bram Wessel, founder and principal, Factor. Bob Kasenchak, lead information architect, Factor. Welcome to the broadcast, and take it away, Bram.
All right. Thank you, Mary D. As Mary D mentioned, I'm Bram Wessel. Thank you for coming to our podcast today. I'm joined by my colleague, Bob Kasenchak. Bob, do you want to introduce yourself real quick?
Bob Kasenchak from Factor. Glad to be here today.
And we want to thank Information Today for hosting a webinar on this topic, which is really timely right now. It's on a lot of people's minds, a lot of executives' minds, a lot of practitioners' minds. And what we're here to talk about today is the role of knowledge graphs in AI-enhanced knowledge management. We also think there's an opportunity here to demystify some buzzwords that have kind of been buzzing around lately concerning different types of implementations or different graph structures. So we're going to be focusing on that today. All right, so a little bit about us as we start here. Factor is, as this mentions, we're Seattle-based. We're an information architecture firm. We also do taxonomy consulting, and more we're finding ourselves building ontologies and knowledge graphs for our customers. We really specialize in that enterprise scale information architecture, helping large organizations, most of our customers are Fortune 500 companies, make their information findable, usable, and trustworthy. That's the most important part, the trustworthy part, especially in this era of AI. So knowledge graphs have really become a central part of the work that we do. And that's really the story that we're here to tell today. So, why graphs and why now? So, let's start with a bit of, and this is a word we're going to be using a lot today, a bit of context. So, I'm going to read you a quote here. Semantics, knowledge graphs, and ontologies are no longer niche domains, technologies for specialized domains, but essential components of AI-ready infrastructure. This was from the keynote at the recent Gartner Data and Analytics Summit that Gwen Hall, the CEO of Factor, and I attended. This is a notable shift. For years, knowledge graphs were seen as specialized tools, the domain of data scientists, information architects, enterprise ontologists, maybe some of you folks on the call today. That has changed dramatically. The reason is AI. As organizations race to deploy LLMs and agentic AI agents, they're really discovering that these tools need structured, trustworthy context just to perform reliably, to not hallucinate, to not run amok, to be grounded in some kind of objective truth. And that is exactly what graphs provides. So let's walk through how this works. So what we're going to talk about today, we're going to talk about graph basics. We're going to talk about different kinds of graphs, especially some that are emerging, such as context graphs and decision graphs. We're going to talk about the role that graphs play in enterprise information layers. We're going to talk about graphs and artificial intelligence. We're going to give you some tips on how to get started. And then we're going to be followed, as Mary D said, by that question and answer. Okay, so graph basics. Now I'm going to turn it over to Bob, who's going to spend a little bit of time talking about graphs in general to provide that background and context that we're looking for. Take it away.
Thanks, Bram. So a graph, as most of you know, is essentially a kind of database, and we should think of it as a database. Most databases, or traditional databases, store data in tables. We call these tabular databases or relational databases. Even if you're not a database person, you're certainly familiar with how data is arranged in spreadsheets, a series of rows and columns in a table, and the tables can be interrelated. This method is great for many use cases, data that is well represented in tabular form. But it's not ideal for semantic data, which emphasizes the relationships between objects. In a table, maybe you have a row of customers and a column with addresses, and the intersection of the customer and the address column is the address of that customer. But there's no object in the system that's called customer has address. It's notionally defined by the cell where those things intersect, but that relationship is implied. In a graph, the relationship is a first-class data object. It can be queried, it can be manipulated, it can have attributes, and it can be reused. This is critical for semantic data modeling, where the relationships between things are emphasized. Graphs are stored in graph databases. There are many such solutions on the market. And for what we're interested in, which is knowledge modeling and management, metadata, semantics, graphs provide a great way to connect concepts to data. For example, taxonomies to content, or taxonomies to each other, or lots of other things that we'll see in just a minute here. Sorry, I lost my place in the thing. So why use a graph rather than a traditional database or a spreadsheet? The short answer is the complexity of the data that needs to be modeled. Graphs are designed for complex, multidimensional connections. They let you represent and query relationships in ways that are extremely difficult in a relational database. Think about the difference between what documents are tagged with this topic versus what concepts are related to this topic, and what documents authored by people on my team published in the last 18 months touch on those concepts. That's a very different multidimensional query. The second query is trivial in a well-designed graph, but in a relational database, it's kind of a nightmare. So for nuanced analytics, metadata alignment, and especially for AI, as we'll be discussing, this kind of richly structured data is essential. We're all very used to dealing with taxonomies, mostly thesauri, which are organized hierarchically. Technically, a taxonomy is a kind of graph, but a very limited one called a directed acyclic graph, and it's limited to broader and narrower relationships and sort of fuzzily defined associative relationships. Ontologies are graph structures. That could be an entire talk by itself easily, but let's say that can contain one or more enterprise taxonomies, and probably do, but that also support more granular relationships beyond hierarchical structures, which are critical for semantic modeling, for the kind of context we want to do, for analytics queries, and for supporting AI and KM. Both are used to model domains, both are used to drive metadata and organizational alignment, and both require resourcing and governance. So while a taxonomy, represented on the left, is a structured classification system that organizes information into a hierarchical tree, that is, each term in a taxonomy has a broader or narrower term, creating a clear top-down structure. In some cases, taxonomies are expanded using thesauri, which is actually what most of us use, if we don't call it that, which introduce synonyms, related terms, non-preferred terms, and other attributes, but the underlying structure is strictly hierarchical. In an ontology, which is also a structured classification system, an ontology is more flexible. Instead of a simple hierarchy, an ontology defines multiple types of relationships between concepts, allowing for more complex web-like connections. So while a taxonomy is a tree, a graph is a web or a rhizomal structure. This is much better for complex knowledge bases. Back to Bram.
Okay, so we're going to go over some graph principles here. Okay, I think there are really 5 key principles that define knowledge graphs and explain Why are they valuable in enterprise settings? One is extensibility. So this is because graphs are built on open standards. You can start with one use case, model it really well, and extend it over time. So the critical audience for advice for this is solve one problem at a time. And as we say here at Factor, don't try to model the ocean. The next one is interoperability. Because they use RDF and W3C standards, RDF structures can be linked to one another within your organization and across external data sets. Reuse. Once you've built a knowledge graph, it can be repurposed for new business use cases. So that investment is no regrets work. That is going to have benefits downstream, and is something that you kind of need to do even if you're not doing a whole lot with AI yet. The next one is machine readability. RDF is designed to be consumed by systems, and that is critical for AI integration. And one of the things that we're really is kind of a mantra here at Factor is things, not strings. Rather than using text strings, free text search, graphs name things using unique identifiers, or what we call URIs, and apply labels for human readability. So, for example, this graph shows that NYC, New York, and New York City are in fact the same thing. So back to you, Bob.
As we were preparing this webinar, we had to sort of determine what altitude to provide information at, and also not to overload it with a ton of technical information. So trying to keep this fairly high level and not too technical, a graph is a combination of nodes, which are the little circles, and edges, which are the lines that connect them. The nodes are objects, and the edges are relationships. Objects can be whatever you need them to be in your model for your business use case: concepts, documents, people, products, or whatever is relevant. All the things you explain in your enterprise taxonomies, plus other foundational business concepts that you need to align and model. So the nodes are analogous to, or really extensions of, concepts in a taxonomy. They can also have attributes and alternative labels and notes and all kinds of other information attached to them. The difference is that edges in the graph are relationships. The big deal, again, is that these are not implications like in a relational database, but they're objects in the system that can be queried and manipulated and even have attributes. So why is this important? Modeling relationships as first-class data citizens, that is, they're just as important as objects in the system, which is a very radical concept for traditional database users, lets you model core business concepts in more detail, connecting concepts in a variety of useful ways so that you can retrieve data more easily, provide critical context to AI applications, and combine siloed data sets for better analytics. And that is a critical point. Modeling core business concepts requires and forces alignment across an organization. What is a product? What is a customer? What is a campaign? These seem obvious, perhaps, but in practice, it's not obvious at all. And having everyone aligned in an agreement on such core concepts is extraordinarily useful. Encoding them in a machine-readable format is even better. So,
okay, yeah.
So as graphs become more widely understood and accepted, perhaps it was inevitable, as a person who deals extensively in matters of categorization, that types of graphs would emerge. And indeed, it seems like sometimes over the last, couple years and even several months, that new types of graph are emerging every week. So we're going to try and make sense of some of these types of graphs. Go ahead, next slide, please.
There we are.
So let's try to make sense of the types of graphs in the current discourse. Researching this topic, it seems to me that there's a lot of overlap around definition and uses of various graphs. Some sources consider a content graph or a people graph a kind of context graph, for example. There's a lot of conflation between context graphs and decision graphs. So here I'm offering some definitions which might well conflict with some sources, but I think that's okay. What I'm proposing is a way to try and make sense of the increasingly muddled terminology in our space. So one point of view could consider all of these other graph subtypes of knowledge graphs, but I think context and decision graphs are distinct enough to merit separate consideration. This is not definitive. Rather, it's an attempt to make sense of each graph type and what each is good for. This could all change next week, but I'm kind of hoping not. So this small table, again outlining the point of view that I'm providing, is not canonical. It's an attempt to compare and contrast the main, as of today, types of graphs. What does each type of graph model? Critically, how often will the graph change? This is critically important for governance and planning. While all graphs require governance, some will change, mostly through the dynamic addition of data to the graph, much more quickly than others, depending on the data you need to capture and model. I've also tried to show what some of the main use cases of each graph are, that is, what information it's supposed to be modeling. And we're going to go consider each one of these separately for a slide or two, but this table helped me organize my thoughts, so I thought it was worth sharing during the webinar. So let's start with knowledge graphs. Knowledge graphs, or KGs, as they're often referred to in the business, are foundational graphs that model and store information about concepts. Concepts, again, can be whatever is relevant in your business use case, and they will probably include and tie together via relationships your enterprise taxonomies. They can also include, and really should include, links to external data sources. It's one thing to have a node in your graph describing Socrates or London or business development, but you can, and should, link that concept using linked data to an external source with lots of other information, like DBpedia or Wikidata. That means you don't have to research and store all of the information about Socrates or London or BizDev locally. You can farm that out by connecting it via a URI link to external data sources, allowing you to pull in information or data as needed. As an extension of enterprise taxonomies, the knowledge graph also becomes a source of truth for applying metadata to assets across your enterprise, just like your taxonomy program, the benefits of which are well understood and don't need to get into today. Knowledge graphs are also great for providing critical context to AI applications, and we'll talk more about this shortly. So, without spending a ton more time here, knowledge graphs are a generic and foundational type of graph used to model and store information, provide metadata, support queries, and serve other business functions. As Bram said, even if you're not doing AI, there's lots of reasons to invest in this kind of semantic foundation. There is virtually no limit to the types of information you can model and store in a knowledge graph, although some specific subtypes of knowledge graphs have, I think, become standard. But before we talk about that, let's talk about where the sort of terminology came from, which was the Google Knowledge Graph. The Google Knowledge Graph pioneered another use case: to serve up information about a concept alongside retrieved content about that concept. This old screenshot from the Google Knowledge Graph shows this in action. I performed a query for optics, which is the branch of physics that deals with light and so forth. And it returns on the left-hand side websites about optics, and basically the standard Google search result when you search for optics. What does it come up with? On the right-hand side is that information box, which is driven by linked data. So you might find information from Wikipedia, you might find information from lots of other data sources, and it has about optics, famous practitioners of optics, what are types of optics, what are some journals that publish about optics, and all kinds of other information with useful links and images. This rich experience is powered by a knowledge graph and linked data. This principle can be extended into enterprise environments, offering, for example, information about a product or service alongside content about that product or service. This is quite powerful, and I think it's underutilized. So let's talk now about content graphs. A content graph, I think, is a subcategory of a knowledge graph that's centered around content. This includes metadata. Instead of having a content management system with a row representing a piece of content and then the tags associated with it, those can be stored in a graph. So it shows where metadata is connected to content objects. So this illustration is about one journal article. It shows the one journal article in the center of the graph, along with the topics, the metadata describing it in the yellow in the upper left-hand side, and also the authors that contributed to the article and the journal in which it was published. Note that this does not replace a CMS. This is not a content management system. You don't store the data, the content in the graph. The content is represented by a node in the graph and then attached to other relevant information about the content across your ecosystem. It can serve as a metadata management tool with some systems integration with your content management systems, but it can also enable powerful queries and insights for content management. So a content graph will have data about the content added fairly regularly. So while your baseline knowledge graph models concepts and information valuable to your business, it'll change and develop, but your content graph is going to need to have data to it every time you publish a new piece of content with all of the associated metadata around it. Because now this slide shows just two pieces of content. So you can imagine how big these graphs get when lots and lots of content are in them. They're very hard to represent in a readable slide. But showing merely two articles and their associations, you can generate a network of relationships showing articles with the same or similar topics or authors or whatever else you want to model. Because all enterprises, whether you're in the publishing sector or not, are now publishers of massive volumes of internal and external facing content. And this audience in knowledge management knows very well that managing all of that content is difficult. And so is generating insights and analytics about the content. Graphs can model the things you're interested in to make all of these things easier and show the network of relationships between your taxonomies, metadata, related topics, and generate similarity relationships, example, for content recommendations and other kinds of personalization. Next, let's talk about a people graph or person graph, which is also a subclass of knowledge graphs in my taxonomy centered around people. It makes sense if you think about it. This type of graph is also more dynamic than a base knowledge graph, as information about people needs to be captured often. Imagine for customers, for example, potentially in real time as you track their behavior on your website. So a customer person graph might include information about what products they own or have bought or even looked at on your website, or maybe even what content that they viewed. Internal-facing person graphs for internal KM can include information like where they sit in the organization, who they report to, who's on their team, what they do, what's their expertise, what skills they have attached to a skills taxonomy, where are they located, what documents have they offered, and any other useful data that you want to model. So that can also be quite powerful. This is great for things like expertise finders. We hear from clients that finding people with specific skills at an org is in high demand. I need a Python developer who also can use left-handed scissors, or however that instantiates itself. And this kind of rich person graph can let you model and query that information. So obviously, this means very likely ingesting data into the graph from multiple sources. So systems integration and data transformation are definitely important here.
Yeah, these are really, really useful in situations like internal HR, sales, marketing. There's a lot of uses for this kind of thing.
And they require constant updating. So now let's talk a little bit about some emerging types of graphs, the definitions around which are less firmly established. So again, we're going to offer our point of view here. A context graph, which is a relatively newly emerging kind of graph, adds additional and very granular contextual information to a base kind of knowledge graph. Things like time spans. When did Alice work at Acme? It's one thing to have a graph that says, Alice works at Acme, but what if she leaves? Or what if she leaves and then comes back? How do we model that in a simple graph? Well, you have to get a little more complex with your graph, and you have to say that Alex worked at Acme from 2009 to 2023. When did Alice live in London? That could include spatial data and especially information like provenance. Where did we get this information? And confidence in the data. How certain are we that this data is right? Can be added in this kind of context graph. The reason you don't want to store this information in your base knowledge graph is A, that base knowledge graph layer should be stable and easy to query, and adding all of this contextual data to it is going to blow up the size of the graph. So the context graph takes things that you're interested in adding really, really granular data about, and provides a method for doing that. So probably it will be connected back to the KG. Graphs are interoperable, as Bram said in his earlier slide. So there might be good reasons to keep these things out of your general KG, because you don't want to blow up the size. But modeling and storing this kind of data can be very useful for decision making, which is why I think it gets conflated with the next type of graph, which is called a decision graph. So a decision graph, which explicitly model workflows and decision trees for AI agents to follow, I think are distinct from context graphs. Again, these concepts are still emerging in the industry, and so we're trying to help tease them apart. You'll find other conflicting definitions in other places, but I'm drawing a distinction here. Context graphs add contextual information, while decision graphs model processes and workflows. Again, lots of potential to use these things in combination. So this example from Flex Rule shows how inputs like risk factors and car types figure into the calculation of an insurance premium. This is the workflow that a human follows when making this decision. And if we can model and instantiate this in a machine-readable form, we can try and have agents perform some of these sort of busy work operations for us. So while one hopes that the final result is reviewed by a human, the idea is to automate some of the information gathering tasks that an AI agent can do to take away some of the busy work done by a human and directing an agent to follow the same process. It's probably becoming clear, again, that combining several of these graph types that we've been discussing can be very powerful.
Yeah, and we want to flag a resource that we found genuinely valuable on this topic. Our friend Emily Winks, she used to come to KMWorld and Taxonomy Bootcamp, so you may have met her. She is at Atlan, which is a data catalog enterprise software provider. Emily has written a really clear and accessible piece outlining how knowledge graphs and context graphs work together, or, sort of what the boundaries are between them. So the link is on the slide here. You can go read that article. And if you're just getting started and you really want a concise overview of these graph types, that's a really great place to go after today's session. So now let's zoom out and focus on or talk about where graphs fit in your enterprise information architecture or your semantic layer. So this quote that I'm about to pop on the screen here from Juan Cicada, who he's somebody in our community who writes very cogently about this stuff. He's a respected voice in the knowledge graph community. This really sums it up. Semantics is now critical infrastructure. That means it's not a nice to have. It's not a specialized tool. It's infrastructure, like your network, like your cloud service, like your security protocols, like your SaaS software. That's a really significant statement. And it reflects what we're seeing in our client work and what we're seeing at places like industry conferences. Organizations that have invested in semantic layers or are investing in semantic layers are significantly better positioned to deploy artificial intelligence, especially agentic AI, effectively and responsibly. So, at a high level, I just use this term semantic layer, so I'm going to define that now. At a high level, a semantic layer is a system or a stack of systems that provides an aggregation and an abstraction layer between your raw data sources and the applications and business processes and users that consume them. So we've always called this the information layer, which is an abstract thing that exists whether you acknowledge it or not. You can think of that sort of as a mediation layer where your data lives in databases, data lakes, content repositories, CRMs, ERPs. We talked about CMS earlier, content management system. The semantic layer gives all of that data a common vocabulary and a common set of relationships. We've created these for several Fortune 500 companies now and provide that internally. They provide it sort of as taxonomy or graph as a service. So a semantic layer provides those data structures that combine information from multiple sources that get integrated into graphs, as Bob has shown here, for specific business needs. It provides standardized terminology and definitions, a common vocabulary. Customer means the same thing, and marketing as it does in finance. Because as Malcolm Hawker said on a podcast that I did with him a couple of weeks ago, when the chief marketing officer asks you, what's a customer? The answer cannot be, it depends. This provides governance and trust, data provenance, lineage, and quality controls. It provides context for AI tools and agents, and that is the thing that LLMs really struggle with. If they don't have the appropriate context, they make all kinds of assumptions. Sometimes they hallucinate, and the risk of using them goes way up. Data products for consuming systems. So there's a lot of focus in Fortune 500 companies right now and large organizations on data products. So how do you make something a reusable data product? This is a way that you can structure, what's in a data product and how a data product works. The ability for business users to query using natural language, and that's the big innovation of large language models, and chat interfaces for them and other natural language processing tools. So, Bob, let's talk a little bit about what this looks like.
So, after generating this slide, I really debated about including it because it's kind of terrifying. I wanted a diagram that shows a notional full stack semantic layer with as many components as possible. Please don't be intimidated by that. Most semantic layers don't contain all these components, and this shows integration with some other systems. And most semantic layers don't need to be this complex, especially to get started. Start by solving a specific problem. Everything here is extensible and scalable. Start with something like documents and metadata and your taxonomies or an ontology to describe those relationships. Can get a simple content graph, for example, up and running fairly quickly. Trying to build everything at once, as always, is a recipe for failure, but it's useful to see how all of these components could work together. Essentially, what's happening is you have data sources that flow down from the top to the bottom of the diagram, and they pick up context, they pick up metadata, they get chunked by an AI engine to be ingested, they get rationalized by an ontology, and then are offered up via an API layer to consumers, both human and machine user consumers at the bottom of the stack. So this wasn't intended to be scary, although I find it a little scary, but certainly there are a lot of things in each of these sort of layers of the layer that you can include in a semantic stack. Because enterprise data is often trapped in silos, and no one wants to give up systems and processes which are in place and working and supporting other business functions. The graph can act as an integration layer, absorbing information from siloed data sources, rationalizing it using an ontology, and structuring it in a single place to be queried and distributed. No other databases need to be ripped and replaced. Let me say that again. The graph is not replacing any of the other systems you have doing operational work integrated in your systems and workflows. The graph is an integration layer which sucks up data from all those other places and rationalizes it in a single place. This is a very, very, very simple representation, obviously. Now, this obviously involves a lot of systems integration. So it's critical to involve engineering resources from the start of any project. But by combining insights and metadata from across various sources, we can start to answer questions like, did a visitor viewing content about a product lead to a purchase? Which is something all companies that provide products and services through their website are interested in answering. So this work requires alignment around core business concepts. We've said that several times already today. The foundational work necessary for any ontology project is aligning around core business concepts. Right now, or in early days or only a few years ago, those were contained in an ontology or maybe a set of enterprise taxonomies. But we want to express the idea that this knowledge graph can absorb all these things and relate them to each other. We had a large enterprise customer, and they had a bunch of taxonomies, hundreds of taxonomies. audience and use case and technology and types of products. And they had a concept and audience called gamers, and they had a concept and use cases called gaming, and they had a type of product called gaming machines. And those things had no relations to each other, across the taxonomies till we started to put them together in an RDF semantic layer. And then once we did that and combined them, we can connect gamers and gaming machines across a graph, which leads to much better content recommendations and related tags, because those tags aren't ripped from a taxonomy and stuck in a field somewhere in a CMS. They exist in a metadata graph system that showed how those things relate inside and outside of their content. So by controlling things like content type and languages and geography and technology and products and audiences, these are all probably very familiar types of taxonomies. We can bring these together in the semantic layer to provide not just a single source of information, but allows you to model and explicate these relationships between these concepts, and further enables tying them together via content and people and other business critical objects. Back to you, Bram.
Okay, so I want to get to the heart of the matter now, because this really brings us to the topic that's on everybody's mind. How do graphs and artificial intelligence, especially agentic AI agents, how do they actually work together? This is where investments in knowledge graphs start to pay off in a very, very concrete way, because knowledge graphs provide a structured machine-readable foundation. That's a really critical word. In Gartner's keynote at the Data and Analytics Summit, they declared this the year of the foundation. This is a year when we double down on our information foundations. And that foundation makes AI applications significantly more effective and reduces risk. So what does this do? It reduces hallucinations. One of the biggest problems with LLMs is that they are designed to, pardon my French, make shit up. Sorry. When an LLM is grounded in a knowledge graph, it has access to structured, authoritative information. That significantly reduces hallucinations, or the potential for hallucinations. Semantic disambiguation. Okay, LLMs work with text strings. They don't inherently know that Apple might be a fruit or a technology company. Or that your internal concept of account or customer might differ between teams. So a knowledge graph adds that semantic layer, adds that level of context. And that's especially important inside organizations. What does a customer mean here? An LLM that's trained on the internet can't infer that. You have to tell it that. Explainability and trust. So a graph-grounded artificial intelligence or an LLM or an agent can cite its sources. Here's the answer. Here's where it came from. And that's critical for regulated industries, for audit trails and also for user trust. I mean, that's what we call provenance. And the reason that's so important is because you need to have transparency and traceability and to be able to tell regulators or other constituents, okay, where did this come from and what did we do to it? So I also want to talk about GraphRag. So that's a sort of a buzzword. Many of you may be familiar with it. Some might not. It's called Retrieval Augmented Generation. That's what the RAG stands for. And that's a widely used technique for improving AI accuracy. And GraphRag extends this by using relational structure of a knowledge graph to retrieve not just relevant documents, but relevant context and relationships. So what you have then is centralized and integrated data. So the graph can serve as that unified data source for AI queries rather than the AI navigating all these fragment systems and kind of saying like, okay, well, I don't know what this context is, so I'm gonna make it up. So what are the practical use cases for graph-enhanced artificial intelligence in a knowledge management context? Okay, one is providing critical domain and organizational level context to AI. This is what we've been talking about, and this is what people are really getting at when they talk about context graphs. And this is the foundation. Your artificial intelligence knows what your organization's concepts mean, how they relate, and what the authoritative sources are, and what is the provenance for them. So for GraphRag specifically, rather than retrieving just semantically similar documents, the AI traverses the graph to find contextually related information. So discovery, helping users discover knowledge that they didn't know existed, surfacing relevant concepts, adjacent content, unexpected connections, all of those things. Question answering, the two use cases that our customers come to us talking about when they're thinking about building something graph related or what they want to do with their internal AI, especially their agents, is where did we put this thing? And I just want to ask a question about something. The agent should know, or the AI should know a lot about our organization. I just want to ask a question about that. So accurate, grounded answers to natural language questions that draw on the organization's knowledge graph rather than just general training data. If you're trained on the internet, you don't know anything about inside this domain. And a lot of that stuff is has been not exposed to the wider internet for very good reason. And there may even be regulatory reasons for that. So if you have a safe environment, and that safe part is really important, a safe, well-governed environment, you can then start to teach your agentic service structure or your AI applications about your organization. And the other thing that this does for humans, the users of this information, is that it lowers barriers to information access, making knowledge accessible to people who aren't experts in your classification system. They can ask in plain language, and then the graph and the AI can work together to translate that into something that a business user who's non-technical can understand. So we're going to look ahead a little bit here. Agentic AI is whatever is on everybody's mind right now. It's kind of the next frontier. AI agents don't just answer questions, they take action. They do things. They reason through multi-step tasks. They even make decisions and execute workflows. So obviously that increases the risk surface, right? The risk parameter. And graphs are foundational for lowering that risk because you can model the workflows. You can encode the steps of a process and what happens in sequence and under what conditions. You can create decision trees. You can encode decision logic in a structured machine-readable form that agents can then traverse. That helps agents work better and faster, but it also keeps them constrained and prevents unexpected behavior or reduces the potential for that. Context for data. Provide the agent with the context it needs to make informed and appropriate decisions. And then that foundational reasoning and inference. Enable the agent to draw conclusions and make inferences based on structured knowledge rather than making it up. So this is exactly where the decision graph type that we discussed earlier, that becomes directly relevant for this. So now that we've talked through all the benefits of graphs, we would like to give you some information. If you've decided to move forward and pursue graph solutions, how do you actually get started? So Bob's going to take us from here.
So obviously we had a lot of content to present today, and there's a lot of technical details that we glossed over, but we do want to talk a little bit about how you get from a huge pile of data to a graph. First, you're going to need some investment in technology, graph databases and semantic tools, and the expertise to use them, whether that's in-house or from someone outside your organization. Because it's really important to get the modeling right and build extensible structures and not model yourself into a corner. And I can't emphasize this enough, having ready-to-hand engineering resources is very important. The difference between having dedicated engineers on your project who know what you're doing and having someone pick up a ticket every time you need an integration is massive. We have a current customer who has an engineering team on their taxonomy and knowledge management and graph ontology team, and the speed at which they can get stuff done is just incredible to us, who are used to working in big enterprise environments with huge IT staffs, but that just gets shuttled around as tickets come up. So the context awareness of the engineer can make a huge difference in time and level of effort. Most importantly, though, I think, is to design around a use case or a competency question or another business problem to solve. Pick one problem that you can't answer. How many hats did we sell last year? How many people that viewed this content converted into sales? Pick a competency question that you want to answer and model around that. You can't model the ocean. You're going to drown if you try. And if you try and model the world all at once, and you can't expect funding and executive patience to run out indefinitely while you get the world modeled. Graphs are by nature extensible. Pick a problem or two, design a working proof of concept, build on that success, get executive buy-in to see how cool the stuff that you're doing is so you can go on to solve more problems with your graph. Most of the work comes from coordinating the people and expertise in your organization who own or control the various data sources that you need. So it's very critical to build relationships and get internal support for this kind of work. And as Bram's been saying, and as he heard many, many times at the Gartner conference, this work is bubbling up from the domain of categorization and modeling nerds like me to executive ears who want to make sure that their investment in AI pays off.
Yeah. So our experience working with large enterprises tells us that durable, scalable solutions need to fit on top of or sit on top of four foundations. These are stability, user focus, models, and alignment. So stability, your core models, your ontologies, your taxonomies, they need governance and version control. This doesn't mean that they can't evolve, but it means that changes are deliberate and managed. So governance needs to be built into the usage of these things and also into the model themselves. User focus is critically important. Gary Carlson and I started Factor bringing human-centered design and user-centered design principles into these large-scale information problems. Who are you building this for? What problems are they trying to solve? What does the business need from this? Never lose sight of the humans using the system, which is easy to do in the current hype cycle of AI. So the models, invest in strong domain modeling before jumping into implementation. So the temptation is to skip directly to solutioning and building, and that's real. You got to resist that. Make sure that you have something, even if you're taking one use case, as Bob said, creating one piece of a model, make sure that that is really well done before you proceed. And that doesn't have to take a million years. Organizational alignment. This is kind of another mantra that we have here at Factor. A knowledge graph that isn't adopted is an expensive art project. You need stakeholders, governance, and genuine buy-in. And an important caveat here is if you're building a prototype and an MVP or a proof of value for a single department, just start. These foundations matter for enterprise scale solutions. For early stage work, momentum matters more than perfection. And this fits very well with how most organizations operate now in agile environments that are very iterative. So start small, but get it right, and then, keep going. These foundations also give your development teams a basis for building more resilient tools. And they give everyone, including executives, a clear understanding of the AI risks and potential failure modes. If you want to do this, you're going to need some kind of graph database. If you want to build an ontology, you need an environment to manage it in, etc. So here is a slide that you can take around in your organization, or you can just use it as guidance with your team. Next week, identify a business problem to solve. Identify what the data sources are, and identify what that in-house or external expertise is that you need to be able to solve that. What Bob mentioned before about engage in engineering early so that you're aligned with them and they understand what you're doing and what you're going to be asking of them. In the next quarter, analyze your current semantic layer. All those kind of things that we talked about that make up that semantic layer, analyze that, understand it, create a topology, get it out of your head and into a set of diagrams, and then build a consensus around that. Again, partner with engineering, because they're going to be the owners of a lot of those systems. And then build and test a proof of concept. So that doesn't have to take any more time than a month or two. That is something you can do next quarter or this quarter. And then in the next 12 months, you're iterating and you're refining the model that you've created. And you're extending it to other areas. As Bob said, knowledge graphs are inherently extensible. So with all of that, we'd like to thank you and thank Information Today for KMWorld for hosting this, and open it up to questions and discussions. So, Mary D, do we have any questions?
Yes,
All
we
right.
we do. And thank you to both of you. That was an amazing amount of information that you just threw at us. Very impressive indeed.
You should see the slides we cut,
questions. I'm sorry, what?
You should see the slides we cut.
Oh, gosh. I'm not sure I want to know. Yeah, we do have a couple of questions from our viewers that are sort of asking specifically about some of the points that you raised. So let me start with this one. Are content graphs the same as a content layer?
Hi, Tracy. So Tracy works at one of the customers that we are doing some of this work with. That's an excellent question, and I would say that it's sort of a parent-child relationship. Tracy's a taxonomist, so that will be meaningful to her. The context layer is composed of many things, including data sources and consuming systems. Context graphs are kind of the way of describing that context layer, and as Bob said, storing some of the context that things like AI agents need to use. So I hope that answers that question.
Are content graphs referring to temporal ontologies?
So I think I understand this question, Thierry. Yeah, I think that a temporal ontology is one of the elements of a context graph.
Yes.
And it's one of the important ones. Getting that timestamp, time-coded information and keeping it out of your base knowledge graph is part of the game there. But other things like specific geolocation, provenance, and confidence all roll into context graphs. So temporal ontologies and all the work that's been done around how to model time spans and getting information on edges like that is part of the battle of the context graph. And a large part of the battle. Thankfully, people have been working on that problem for a long time. A lot of that work, interestingly, comes from cultural heritage spaces, which we don't see a lot of because we don't play in that world, although we have some colleagues who do. But like this timestamp thing, when something was created, when it was stolen, when it was sold, and all these things, when you're tracing provenance of things, help develop the methodologies that we use to predict, to put the temporal part of the ontology in the context graph. I think that answers your question.
Fascinating. Cultural heritage, that would not have occurred to me. That's really interesting. Okay, let me go on here. This is a bit lengthy, so bear with me here. With an AI team that is focused primarily on just building more AI agents and tools, how would you recommend helping them understand the importance of a knowledge graph in order for those agents to be more successful?
You can use the fear method and you can use the benefits method. The fear method, there are actually some resources out there, things that we've been reading recently. There was a paper published by Stanford where they sort of demonstrated that when you get into a corpus of documents or content items above 10,000, that the vector model of sort of the similarity-based model really declines in effectiveness. And it's not just that it slows down the effectiveness, it actually starts to go down and craters. So there are things like that. And then there's also the benefit method. You can show, yes, we run into this all the time. The impulse is like, oh, the machines are amazing. Let's let the machines do everything. That's the first impulse of a lot of engineering teams. So what you can do is you can say, okay, there's a difference between probabilistic That's what the LLMs do, and deterministic. And you need both. If you don't have a deterministic framework or baseline or foundation, then the agents are just going to go make things up, because most agents these days are based on LLMs. And that's going to, that gets back into the fear question. Like, what is the risk of agents running amok with your data, especially in highly regulated environments? If you can articulate that risk and show the engineering teams, like, you might do something that really messes our stuff, really wrecks our stuff, then they'll start maybe to listen better.
Okay, I think we have time for one more. If you could give a quick answer to this one. Can knowledge graphs be employed with MCP-driven applications? And first explain MCP.
Sure.
Yes.
Model Context Protocol. Yeah, go ahead, Bob.
Yeah, so MCP is Model Context Protocol, as Bram just said. The best way I've heard to explain what a Model Context Protocol is, it's the USB drive for your LLM. It's how you give your LLM permission to access other systems and files and do stuff around your network. And the answer is yes. Knowledge graphs are great for Model Context Protocols. I don't know if I'd want to give it permission to edit my graph, but you certainly want to give it permission to access the graph. So the way I understand it is you have a sort of prompt workflow, and as part of that workflow, the AI agent needs to go reference the knowledge graph to answer a question, again, to get grounding around things, to go things, not strings, to add some semantics to it, and then bring that back. So absolutely, we're working with at least one customer who's plugging knowledge graph stuff in using the Model Context Protocol. So
yes, that's exactly right.
Yeah.
This customer
if you haven't heard about Context Protocols yet, you're going to be hearing a lot about them pretty soon. Sorry, Bram.
This customer has a taxonomy as a service, is what they call it, which is evolving more into a graph. And they have created an MCP for their internal taxonomy as a service. So that is helping ground some of the agents in this shared vocabulary. That's what the task, I guess you could say, is. It's that shared vocabulary.
Great. Well, unfortunately, that is all the time we have for questions today. And we apologize that we were unable to get to all of your questions. But as I stated earlier, all those questions will be answered via email. So thank you so much to our speakers today. Bram Wessel, founder and principal of Factor. Bob Kasenchak, lead information architect at Factor. If you would like a copy of the presentation, you can download it once the event is archived. And if you would like to review this event or send it to a colleague, please use the same URL that you used for today's event. It will be archived for 90 days. And you will also receive an email once the archive is posted. And this does conclude our broadcast. Thank you for joining us.